So the agenda of today is classification using Scikit learn, and first of all I will import the libraries numpy, pandas, matplotlib, sklearn, cborn, and warnings. The library of warnings just does like if there are updates in the system, it will remove the warnings that come due to those updates. Uh, then we import the data. The data is basically about Titanic. So how many people, showing how many people survived in Titanic and what was their name and their age groups and gender of people, how much ticket, how much fare did they give, and what was the cabin number of the passengers and how many total. So this is actually our overall idea this of our data set, and we get the shape of our data and we load the head of data just to get an idea of how our data looks like. We have our passenger ID, so how many people survived, the name of people. 1 means survived and 0 means he's dead. Passenger class, the socio-economic class of passenger, what was the name of passenger, what was the gender, age, and similarly all of the other features as SIBSP, patch, ticket, fare, cabin, embark. So what we are gonna do is we're gonna implement all of the different machine learning algorithms on this data, and we are going to train data on this algorithm. First of all, what we do is with the help of different plots, we will get an idea of how our data is behaving, what are the outliers in our data, and what are the values that we do not need, what are the columns that are unnecessary we will just remove so that this does not affect the output result of our data. We have made distribution plot between parse and count, and similarly a kernel density plot that actually is between age and density, and then similarly these are all plots that actually give us the outliers in our data. And then this one is a bit important. uh, we have divided age by fare, and this data actually shows that passengers aged between 30 and 40 have paid the maximum fare, and the passengers over 80 between the ages 70 and 80 have paid less fare. So typically more fare is paid by males, and this data shows that lesser fare is paid by females. Similarly, we have made some scatter plot, and just to point out these outliers, these two blue dots over here are outliers, so we will definitely remove these outliers. After that, we make a line plot, uh, categorical plot basically shows us the passenger class and the people who have survived. It is a graph between the passenger class and the people who have survived, and you can see that males who were in second class, males who were in third class survived the most, had the most little survival rate. Similarly, we have made strip plot, and all of these different plots, the purpose of making these different plots is they help us identify the outliers and the exaggerated data that we will have to remove just to get the accuracy better. Similarly, a swarm plot, and then we will have box plot. Box plot, this one is a bit important. Uh, so what does the box plot is showing is uh, this is the maximum range, and on the bottom we have the minimum range. Similarly, this is the median, the middle line is median, and this is the lower quartile range, and this is the upper quartile range, and the area of the box shows the dispersion of the data, and these circles above are the outliers that we will have to remove from the data. While and plot, it basically shows the same thing, like the median and the minimum and maximum value and the data dispersion and upper and lower quartile ranges. Count plot we have. So all of the purpose of doing all of these graphs is basically to actually get an overall idea about our data using different graphical techniques. And then what we are going to do is uh, we we have we will use the info function uh, just to get an idea of how many values are not null. You can see there are more values in the cabin feature and the age column that are null, so we'll have to remove these two columns. And we will remove this one. Is the most important, heat map. What does heat map do is it will show us that which columns we will have to remove. It is showing us the null values in our data. You can see that in the age column there is a lot of data that is 0, and in the cabin data is full of null values, so it is better to remove these two columns. Box plot. And then we will use the imputation function, because the wealthier passengers in the higher class tend to be older, so we will use average values to impute based on peak loss for age. So we will use the imputation function. And then, as I said, after reading all of the data, we have decided to drop certain columns. We will drop the cabin column. X is equal to 1, x is equal to 1 stands for column, and x is equal to 0 stands for rows. Similarly, we will remove the rows with missing data using the drop na function. And then removing unnecessary column. By taking a look at our data, we came to know that the name and ticket column were of no use if we want to predict how many people survived in the Titanic disaster. So we will just remove these two columns. And here you can see those two columns have been removed. And now we have used the describe function to get a numeric summary of our data. What is the total count of our data, what's the mean of all of the columns, and standard deviation, minimum. 25% values are under this numeric digit, 50% of the values are under this, and 75% of values lie under these values. And what is the maximum value that is in those columns. And then we will split our data into xtrain and ytrain. And so we will use the xtrain and ytrain, and we will split a full data set into input and target variables. Input are variables or feature variables, and output variables or target variables. So we have made a variable called x, in which we will store all of the columns except the survived column, because that is what we have to predict. And in the y column, we will use the data that we want to predict. So we want to predict the survived data, so we will use the survived column in the y variable. Now we will train the data using the we will split the data into xtrain and ytrain using the train test split module from sklearn. And then we will use the logistic regression model from machine learning to get to train. We will train the data on logistic regression model, and by using logistic regression function, dot fit actually trains the data, and here our data has been trained in just 3 simple steps. Then we will get an accuracy. So logistic regression models give us an accuracy of 82.02%. Now we will train different models, different algorithms. We will train the data on different algorithms, and we have trained this data on decision tree algorithm, and this gives us an accuracy of 78.09%. We have then trained our data on random forest classifier algorithm, and this gives us an accuracy of 82.58%. And then we train our data on gradient boosting classifier algorithm, and all of these algorithms, the difference between all of these algorithms is explained, and is that just the name of the algorithm will be used as the function. Like when it was logistic regression, we use a logistic regression function, and now it is gradient boosting classifier, so it is the gradient boosting classifier function. Dot fit actually trains the model. And similarly, we will evaluate a gradient boosting classifier, and we come to know that gradient boosting classifier gives us an accuracy of 84.27%. And then again we will actually combine the results of all of the four algorithms that we have trained, and we get to know that gradient boosting classifier was the better algorithm, which gave us an accuracy of 84.27%, and decision tree classifier was the lowest model that we can use on this data, because it gave us the lowest accuracy.